and non-metals. Physical properties of metals. Let us take for example the ornaments. Any ornaments will do. You will observe that most ornaments are made up of gold and silver. Let us have a close look at them. Do they have a shiny surface? Or even the aluminium utensil in the kitchen, does it shine? Of course it does. Both gold and aluminium have certain shine. Do you know what this shine is called? Well, it is called luster, and as both gold and aluminium are metals, this is known as metallic luster. So we know now that metals have metallic luster, and it is one of the characteristic property of metals. Next, if a utensil is dropped on floor, does it break into two parts? No, right? This is because metals are generally hard in nature. However, this hardness may vary from metal to metal. A very thin plate of gold can easily be broken with little pressure because it is thin, right? Wait, did I say plate? Plate of gold? How do you think huge aluminium sheets are made? Or sheets of copper or zinc? If I take a hammer and beat them, will they break or will they turn into sheets? Yes, metals can be beaten into sheets, and we call this remarkable property as malleability of metals. Most metals can be beaten into thin sheets, so this is one of the characteristic property of metals. Now, do you know any other property of metals? Okay, have you ever seen these copper wires or thin gold wires used to make jewelry? Metals in nature can also be drawn into wires. Do you have any clue to what this property is called? Well, it is called ductility of metals. The ability of metals to be drawn into wires is known as ductility. There is an amazing fact I want you to share. A single gram of gold can be drawn into 2-kilometer long wire, and hence gold is the most ductile metal. So this is an important point to note here. It can be a 1-mark MCQ where they will ask which is the most ductile metal, and it has to be gold. Okay, because a single gram of gold can be drawn into 2-kilometer long wire. 2 kilometer is almost 2000 meter, right? So thus we can say that gold is the most ductile metal. So till now we have studied the metals and their 4 properties, right? These are metallic luster, malleability, ductility, and that they are hard. So can you think of any more properties of metals? You are missing an important property. Okay, so let's go there. Metal utensils are used for cooking, aren't they? Why do you think only metals are chosen for it? Why not any other substance? Okay, so which energy do you think we need to cook food? Yes, heat energy. Correct. We need heat energy to cook food, and metals are good conductors of heat. They help to transfer heat evenly throughout the surface and provide even heating. No doubt, most metals are known to be good conductors of heat. To verify this conduction, let us perform an activity. Take an aluminium or copper wire and clamp this wire on a stand. Fix a pin to free end of the wire using wax. Heat the wire with the candle near to the place where it is clamped. So an important point to note here is that we are heating near the clamp and the wax is at the free end of the wire. Now when we heat, what do you observe after some time? You will observe that after some time the wax melts and the pin falls down. Along with it, the metal wire, however, does not melt with wax. So these are 2 observation points we will be observing here in this activity. See the first one. We have said that the wax will melt after some time and the pin will fall down. Now why do you think this happened? See, we are we are heating the metal wire far away from the free end, right? It's near the clamp. And still the wax which is at the free end of the wire is being melted. This is because it is conducting this heat. Okay, so the heat which is near the clamp is literally conducted towards the free end, and this is why the wax melted. And because the wax melted, the pin fall down. So this was the first point to note here. Second one is that the metal wire does not melt with the wax. Okay, so we know, right, every substance or every solid substance has some melting point, and after reaching the melting point, it will melt from solid to liquid. Remember the definition of melting point? Yes, the temperature at which a substance changes from its solid state to liquid state is known as melting point. But over here, the metal wire does not melt with wax. So, by these two observations, we can conclude that metals are good conductors of heat and metals have high melting points. Good conductors of heat is because we have heating the metal wire far away from the free end, and still the wax which is at the free end is melting. This proves conduction in metals. And second point here is that they have high melting points. This is because metal wire do not melt with the wax, right? So we have concluded this activity with two important points. Now, do you know two best conductors of heat? Yes, they are silver and copper, while lead and mercury are poor conductors of heat. So this was all about conduction of heat. Okay. Electric wires are also made up of metals, right? Why is that? Because if we have a battery and a bulb connected in a circuit, with a metal wire, you will see that the bulb will glow when the switch is closed. Okay, so here we have taken a battery, a bulb, and they are connected in circuit through metal wires. Okay, the wire we are using here is of metal. Normally copper wire is being used. So we are using this metal wire, and when we switch on, you will see that the bulb is glowing. So the bulb will glow only when it gains or when electricity flow is conducted through the circuit, right? And now this proves that good conductors of electricity are these electric wires, right? Like these metal wires which have been used in this circuit are good conductors of electricity. They are coated with rubber-like materials, which is normally polyvinyl chloride. This rubber material acts as an insulator, which protects us from being electrocuted if we touch the wire by mistake. So, this is an important property because normally these wires are made up of copper, and copper is a good conductor of heat as well as electricity. So what happens is, if by chance we touch any of the wire, we can get an electric shock, right? And to prevent this, the wires are insulated with polyvinyl chloride, which is a rubber-like material to protect us. It acts as an insulator. Okay, so basically it prevents us from getting shock. So now we have learnt about lots of properties about metals, right? Do you have any other property, or do you remember any of them? Yes, you are still missing an important one, and which we normally see in our daily life. Okay, so let's get there. What happens when metals strike a hard surface? Do they produce sound? Like utensils banging in the sink. Okay, so don't go now near the kitchen and don't bang a utensil in the sink. So yes, utensils while banging in the sink produce sound, and this property of metals is sonority, and we say that metals are sonorous, meaning they produce a sound when hit against hard surface. So if you bang a metal utensil near the sink, you will actually hear this sound. An important application of this is school bells and church bells, or bells in the temples, which are made up of metals. So now let's have a quick recap of what we have learned here in this module. We basically have learned about the properties of metals. So metals are lustrous because they shine. Metals such as aluminium, gold, and this shiny property or this luster is used or is the main emphasis of ornaments that we wear, right? So metals are lustrous, that is they shine. Metals are malleable. By malleability, we mean that metals can be beaten into thin sheets. Okay, thin sheets of aluminium, copper, zinc are produced, right? Another property of metal is ductility. The ability of metal to be drawn into thin wires is known as ductility. This property is used in copper wires as well as gold wires, which is normally used in ornaments. Also, these copper wires are used in an electric casing, right? Next property is hard. So metals are quite hard. Next property is good conductors of heat. So metals are good conductors of heat as well as electricity, and we have proved them using two different activities, right? And last and the most important one is sonorous. So metals are sonorous, and the most beautiful application of this is the bells we see in our schools, in the churches and temples, and so on. So by this, I conclude this specific topic or module of metals. Now that we are done with metals, let's have a look on non-metal. Okay, so meet you in the next module. Thank you.